Okay, Laura, did you have a question for us?
I have a question. It's not about the science. I've been hearing more and more about if OSTP is not going to be stewarding all these projects, and it was brought up, what if DOE was the agency that might be able to run something like this? But Roger and I have been talking to different people and through our Office of Public Affairs, and one thing that has been coming up is these agencies actually working together, a coalition of agencies. And this report itself was sponsored by several agencies. And I was wondering if this study couldn't be a way to go forward and make some kind of coalition between NIST, DOE, NSF, et cetera, DOD.
Yeah, sure, that's exactly what I would do. I think probably, if I were still a federal employee, I could find somebody who would take it upon himself or herself to reach out to the other agencies and to get a working group going. And in fact, that's what OSTP did. There was always a liaison from OSTP, but mostly it was the agencies getting together and talking through it. And it's pretty easy to do what needs to be done to make a short 10, 15-page report defining what every agency's goal and interest is in the activity. So yeah, that's easy.
Other questions? I might.
Over here, Rob.
Oh, I'm hard to see.
So a couple questions and a comment. So a lot of, at least as my understanding, some of the motivation for Eli was to bring in Eastern Europe into the Western European society, if you will. You look at where all these the pillars are, they're all in former Soviet bloc countries. So it was clearly a motivation at some level that Moreau was able to take place of. That's not talked about in your report at all. It's just that they're doing this, and the laser lab is a good thing. But I think that's an important part we should recognize, at least my understanding. The other thing, there has never been an agency in any of the federal government has been a steward of lasers. I mean, high energy physics, had a point where we're going to advance accelerated technology. The petawatt at Livermore, I was there. It came out of laser, LDRD funds. No one was interested in it. Well, I can tell you that for a fact, because when it was done, no one wanted to keep it funded. Todd got his laser to a large extent because K. Bailey Hutchinson was interested in having resources in Texas. Wim got his laser because of the money that was done after the American Recovery and Reinvestment Act. There was something there. So no one has been a champion for this. NSA, we were able to do petawatts because NSA and its former agencies invested in the ICF. The Mercury laser, which was the basis of Happles, it's something, a lot of stuff going on, was a congressional ad back in the 90s to build average power lasers. No one was interested in it at the time. And eventually came the successful program. So how are we going to make it different now than it was back then to get someone who really wants to champion this? What's the what is the right agency to do this?
I guess of course, I don't know that anybody has the crystal ball that's going to give the right answer to your question, but I do have an answer. And that is something that needs to exist first, is the coordination of the community. That is, the community has to be, this is in fact what happened in high energy physics, which is one of the successful examples that you pointed to, and Pat pointed out that they lost that at some point, became fractious. But communities, look, not everybody in the United States decides to do to have their career in science, or even in technology that's directly related to advanced science. In fact, I venture to say most people in the country don't do that. Okay, and so what do they like to support? They like to support a clean, unified vision of an exciting future outcome, and that comes from the community that has the stake in that outcome. So I think that if I had to say, well, what do we have to change so that all of those examples about how nobody was interested. When you say nobody was interested, you didn't, of course, mean the scientists doing the project. They were interested. What you mean is that the agencies that would have to sign off on funding that project was the difficulty. Those agencies, and in fact Congress also, respond to a level of excitation, of excitement in the general population, not only the general public, but also in subsets of it. The science community being an important subset. If the science community is excited about something in a unified way, even LIGO can happen. And did, by the way. Right.
Final questions. Please use the microphone, please.
So, two questions. One is, can you expand a little more on what you were explicitly thinking about when you talked about co-location? And kind of as a follow-on to what Mike was saying and what Pat was saying, in what office would you envision in DOE that this be embedded? Because, pardon? Yeah, but in DOE, where would you, in what office, where do you put it?
Well, we know that NNSA already supports work of this kind. We know that the Office of Fusion Energy Sciences already supports the MEC end station at LCLS. I probably would start by chatting with those guys and asking if they're willing to sponsor a couple of workshops to flesh out the science. And I'd ask them, so who among your colleagues should we go talk to in other agencies and even in the same agency, and start that way. Start by people who are already interested and already funding and see where that gets you. That's probably what I would do.
That co-location, so what we pointed out in the report was the importance of co-location, and there were a number of examples. It probably wouldn't be appropriate in a report of this scope and with these people on it to choose which of those examples are our favorite. I think different members of the committee probably had different favorites. I see one of the members of the committee nodding his head in approval of what I'm saying. I'll just give you two examples. And they've both been given in previous parts of this discussion, so they aren't new. One of them is, it's very, very useful. In fact, there's a tremendous leverage if such a laser is located at an ultra-relativistic electron source. Now, of course, one of the uses for petawatt lasers is to make an ultra-relativistic electron source. So you might say, well, why don't you just do that? But let's just say that we're in our current decade and not a future decade. And there are conventional ultra-relativistic electron sources that are already available. So that's one place for a number of different reasons. I think Tom referred to non-perturbative QED. That's certainly an important one. And then the other class of major facilities, of course, are the high-energy lasers, where at least in this room, people will understand immediately that high-energy lasers are not high-intensity lasers. And Peter gave a little bit of a discussion of that. But their co-location can be extremely important because the things that the high-energy lasers can do are create high densities, high pressures. The things that the high-intensity lasers can do is produce very, very extreme temperatures, high extreme non-equilibrium conditions even. And co-locating both of those capabilities multiply the science enormously. So there's two examples.
Yeah, that there is already a co-located facility at Livermore with the megajoule laser for creating high energy and density and the arc addition to that, which chews up one of the beam lines to make short pulses and X-rays to probe. So that works. I mean, clearly it's such a dedicated facility to one job, but it shows it makes sense. And Constantine, you can comment since you were involved in ARC, correct?
You forget EP and omega, the same thing.
Okay, sorry. Oh, yeah. So there are two examples. Excuse
We
me,
should,
of-
yeah. So I think it's a great answer, about co-location, but a very quick remark, Constantine?
Oh,
It's a short question.
Is the
Can you use the mic, please?
So it's the chicken or egg problem, which is, did you get actually a feeling how far behind the U.S. really is? And, I'm talking not about the amount of petawatts, the amount of facilities, the amount of shots you can do per day. I'm talking about the talent. Because Europe was leading, and so Europe, or is leading now, and has a number of facilities. Asia is coming up too. And so there is also the problem of drawing talent over into these other countries.
Okay, great question. Maybe very brief answer. Phil, do you want to take that?
Okay, very brief answer is that there is more than one way to quantify it, but it looks to us like sort of at the level of 80% or so, the momentum is with the Europeans. In terms of, for example, we make wonderful lasers here of this quality, and we sell them to Europe. Well, how many of them do we sell to Europe? About 8 out of 10. Okay, so it's sort of in that ballpark, and so that's not an insurmountable lead. In fact, it isn't really a lead at all. It's more of a question of where you put your resources for advancing the next generation.
Okay, I'm going to call on Eugene Arthurs to make some final comments. I do want to throw out one question we can talk about at the reception afterwards, which is who has been left out of this report? There are many needs for lasers in this fields of science, long pulse lasers, high repetition rate lasers for things like accelerators. It would be good to discuss who should be brought on board as a next step as well.